But yeah, no. It's good. Oh, wow. Yeah.
We were basically making sure that it worked properly and just troubleshooting it a lot. And so the project overview, the goal was to create a walking hexapod robot using the Raspberry Pi. And then the tools we used the Raspberry Pi, Hexapod, Python, Mac, and then some tiers. The focus was like robotic movements, and then power optimization and the server controls. So yeah, the hardware components, we used the Raspberry Pi. So that was used for the logic and the controls. The six-legged servo structure. So the Hexapod has six different legs here, and they all different servos. And so we have the IMU balancing sensor, and so that one is to help the robot with like balancing when it's like walking. And then the GPIO pins are basically the pins that are used for the legs to move around. And then the hardware component, you use external power source with like different power management adjustments. And so we can change it, we can change the coarse current or the fine current or coarse voltage and the fine voltage. And so here is, so over here is the power supply and it's connected into the hexapod. And so I have a video over here. And so we're just testing these, making sure that the board is getting electricity to it and making sure that like all the legs are able to move and play together. So yeah, that one was really cool. And then okay, so troubleshooting the Hexapod. So when we first got it, we didn't really know much about it. And so we downloaded the GitHub repo of it, and we went over different code and different like tests that we could run on. And so I did a couple of different files. I did the control Python file, the single leg test, the test, and then the walking demo. Um, I can't go over the file, but it is a lot, so I guess we'll just skip over it for now. And I'll just explain what the demos do. And so this video right here will be part of the test Python code that that helps make sure like all the legs are moving and are able to be calibrated correctly. So yeah, so it puts all the legs up and then make sure that it goes down. And so that one was really cool. And then for the walking demo, let's see. It's a
No, that's like the word go big or, I don't know. I mean, it sounds like you can swap over to like L. Yeah, there it is. From the volume a little bit, just, is the sound on your end all the way up? Yeah, that's all.
Yeah, I can explain it.
Oh, here we go, I got it.
Okay.
Give it a go.
Yeah. Yeah. Should be calibrated on, but it should have three legs. And then the other three support. That's what the link is.
Yeah. So for this walking demo, there's two different types of walking, and we call it gaits. And so basically, there's two.
You want moving stuff over, you want to bring that one over?
No, it's yeah. I'll move over the thing over here. Okay. And so the walking gait, the first one that I use, you can see that there's 6 legs, and so these two right here are going to be moving. Yeah. And then these two over here are going to be moving as well. And so you'll see it in the video. Yeah, that's the first time I got it like walk, so it was a little exciting.
You can just wait. These three. Oh, these. That should make it. So these two right here. Or if you walk forward. Oh, that's so cool.
And so yeah, so I was able to get it to start walking, but since it was like in a lab, we weren't able to get it on the floor walking because the floor.
Was cool.
Yeah, the floor was too smooth, so it kept slipping up.
Okay, so we're
Okay. And so some of the major challenges was like the blackout. The Raspberry Pi moved a lot on different movements. I didn't have a good understanding of like how electricity worked and like how current basically was. And so yeah, that was a whole new thing to like learn. But I was able to figure out how much voltage and how much current it should need. And then the servo angles, so where the leg is positioned at, it's like different angles, and uh it wasn't moving the way that I like intended it to be. And so it was it was a lot of learning and a lot of trying to debug the code and trying to figure out what was going on. And then uh none of the code that we got from the repo was commented, so it was me simply none of the code from the company that sent it. Uh it wasn't really documented, so like you just see a bunch of like words and you don't really understand what's going on. So I spent a lot of time trying to like put it in English and then try to explain like what's going on. And I was able to get a couple functions and understand what was going on. And then the GUI, which is basically like an interface for the robot, it wasn't connecting properly. And so I made this PowerPoint before I got it to work, but now it works. So I can demo it. And then the lessons learned, like personal growth, a lot of patience, persistence, and then problem solving under pressure. and then hardware software integration, and just a lot of debugging. I had to document each step for the troubleshooting, and I just made tracking the issues easier. And I gave structure to my test. And so for the technical takeaways, really power supply matters. Raspberry Pi blackouts solve a lot of issues. And then the servo controls are very delicate, and so the way the legs work, if you can really misconfigure the coordinates easily. And then just testing in isolation. So not trying to test the whole robot, but just making sure that you can test one leg at a time, and making sure that it's a lot easier when we break down problems. And then a lot of it for the code structure importance, and so just understanding the different modules and how it works, and just understanding the code and what's going on exactly. And then so for the future work, I was hoping that we can get the hexapod walking on a flat surface, and then just understanding the gates better, the walking habits. And then I want to add vision and object detection. And then just upgrading the robot with a camera module. And then integrating OpenCV and CNN models. So basically using AI for it to detect different types of objects and different types of plants, which would be the big main idea of it. And so I have a demo of the GUI working, or the interface for the robot. And so here's the interface for the robot. Until I press it, every time you press the buzzer. Oh yeah. Device. It was. Put in my press. Oh. Yeah, so it gets stuck, and so it's not relaxed at all. This balance. So balance would be able to just put it on a floor, and then it'll stand up by itself. So there's a lot of and then I can show a demo by yeah, that was it. I think the robot.
And this data,
Uh,
or is it just temporary?
Alright, it's the furthest I can go out.
Oh, that's nice. I'll just
Okay.
hold the camera. Thank you.
So I'm gonna run a single leg test, and so basically it's gonna recalibrate all the legs into the starting position, and then move this back leg in a different position. And that's how we're able to test the single leg. So as you can see, this single leg is different because I set it at a different angle rather than these ones that are already calibrated for the starting position. And then, so for the servo, gonna be running another test where if it falls down, it'll lay all its legs out. And then it'll stand up by itself. So yeah. So yeah, then it's recalibrated, and it makes sure that it's standing up. And then for the walking demo, here's a better one. So you can see that these two and this middle one, they move at the same time, while these two and this middle one move at the same time as well. So it's 3 by 3, basically. Yeah. And then for then I can run the interface and I can make different types of like sound and move it like specifically for it. So now it's connected, and so like I don't have to be near it, but it'll be like, oh, I want the buzzer. Or if I need to use like the ultrasonic, you can see that, oh, it's very small, but you can see on this interface, 67.6 centimeters. That's when it detects something. So if you were to like move your hand closer, yeah, the number should get smaller. And so it has an ultrasonic. Then and then for this one, these are reverse. The calibration, I can see different legs, and so if I want to move leg one, like 90, 79. But or if I want to do, say, I want to go out more. Go back up. See what I did? And that's the calibration for it. And balance, it should balance out. Relax. Relax. It's relaxed. And so I can move the legs however I want, just to make sure we get the starting point. But if I were to, like, I can, not relax, and then, like, the legs are stuck in this position. So. So yeah, that's the presentation. Do you have like any questions or anything? Oh, it shows on there too. So you can see right here, like it records like the distance for it. Yeah. All right. Well, thank you guys.
Thank you, Nate.
Thank you.
So we've been here to kind of swap out here for a sec.
It's got wipes, thank you. It's recording.
All right, so hi, hello, thank you all for coming, and for those of you online for watching. My name is Daniel Kerry, I'm a student here at Evergreen. And I have some objects for you here from some things that I've made in the past, over the last few years. So we'll kind of switch up here. Awesome. Yeah, looks good. See, okay? Fantastic. So I do promise everyone that I am a real glass blower. So here's kind of a little warped. So this is a hollow vessel. It's kind of a form that I've been kind of playing with, kind of trying out different methods. Not trivial, but kind of fun to practice. I also make these kind of spiraled bubble double helix. So inside you'll have a bubble there. It's all continuous through the entire piece. So it all, yeah, two bubbles, all spiral together. It's a kind of, again, kind of a practice piece I like to make. Some people, glass blowers, they'll make full ponies. I like to make these little spiral friends. And I also do 3D printing as well. So this background here that we have, this is an ABS, which is normally kind of a rigid plastic. However, this pattern here is a gyroid pattern, which gives it some interesting properties. I can flex it, bend it, and it's not permanent what it is that I'm bending. It has have kind of different strength in which direction that you kind of play with it a little bit. Also kind of fun. See here, kind of gives you just some optic qualities, really great for cases, things like that, which we will see here shortly. Also designed these, so we'll kind of zoom in here. I have these little baby boxes, so these are kind of print in place. They have 4 little hinges in there. No assembly required, and that's that same gyroid pattern as well that you see at the top there. The latch itself is a compliant mechanism. Nice little button. I've also designed some ways that you can attach to this system. So again, compliant mechanism. We have these little jaws in here, which allow me to kind of attach back on this kind of system. Can be printed at different angles. It's kind of have a lot of freedom with that. Also have here, there's some filament that's a little bit challenging to print. So this is a belt extruder that I'm working on. Want to assume that there's this one, we have kind of herringbone gears at the top. We have one larger gear all printed to a smaller gear at the front. It's there, and you start to combine glass and casting and 3D printing. You can basically get kind of 3D printed molds for glass. So over here we have kind of an ABS ball. We have just binder clip at the end. Inside, it's TPU. All right, nice and flexible so that when you cast something, you can remove this TPU part from that casting. In these little slots, I can print out some parts that'll give me different patterns. And this style of kind of casting and molding to make these pressed pieces. So we're gonna have some slots or channels in the back, and patterns in the front. Upside down or right side up, I don't know which, which way it's going on here. This is all glass. It's a kind of soft glass, so it's compatible with furnace glass. We can pick this up in the studio. It's also compatible with all the neon that we have in this room here, right? This is all kind of soft glass tubing that we're using. Another kind of pressed piece on both sides. And I've been recently working on developing kind of an injection molding system for glass. So again, we have ABS walls. We open it up here. Again, we have this kind of cord system. This blue here is a wax. So again, this is the material that's really kind of challenging to print. On top that it is flexible. So it tends to, it's like, pushing on a rope. You do run into some challenges. The gears will dig into the wax as well. So that's kind of the reason for developing this kind of belt extruder to really grip onto this wax filament. And what you get when you start to press this glass, here's a piece here. Zoom in. So this is without any back pressure, right? If I just let the glass fall and I let it do what it wants, it's not really going anywhere. However, put in some back pressure, we're able to fill in all those spaces. And so this one here is about a 2 millimeter diameter. I was able to also get a 1 millimeter diameter as well, to get pretty far down. So you can really get these very, very fine features. Also again, this kind of gyroid pattern, all glass. This has the screw as well, just kind of give you an idea of what's going on with the process. Some more injection glass. And then here we have one of the more successful prints. So what we're seeing here, right, is that we're kind of have the glass, right? We have another kind of 3D printed part. Allows us to kind of make a little press piece that we can push glass into the mold. Nice. Got some more, so again, kind of different colors, glass. Also, we have here. So this here is, let's see if I can. This is a printer. It was basically on a Voron 2.0 or 0.2. It's an open source project. I've designed here. Oops. Kind of a whole outside shell to the printer, all custom made. Good. Inside look there. Swap over. So this is all the custom parts in an exploded view. Kind of how more or less where they're fitting together. So yeah, this is my presentation for kind of digital to glass fabrication. And the kind of interesting things that you can do when you mix 3D printing and glass. So yeah, any questions? Concerns, comments?
Especially with ceramic.
Sorry?
So it basically lost wax.
Yes, and the difference is,
Putting a ceramic into the 3D print and then casting glass.
so I'm using, there's a mix called R&R 910. It's kind of an industrial mix. It's proprietary. They don't tell you exactly what's going on inside there. But yeah, I cast that and then the glass just goes into this R&R 910. But I do believe it is a kind of ceramic.
It has to be what we're standing.
So yeah, in traditional, we use silica, like a 1-to-1 silica plaster mix in a lot of glass casting. But I find that the engineering qualities isn't quite enough to be able to really put pressure into the mold.
Yeah, that's more like traditional investment.
So, yeah, and then moving forward, working on kind of work more to borosilicate glass, so more of a tougher, stronger glass, to kind of develop microfluidics, and then as well as kind of glass hinges, so glass living hinges is kind of the next step for this process. Awesome. Yeah, cool, awesome, thank you. Yeah, so, yeah, welcome to come on up.
Thanks.
Yeah. Yeah, so that's what's nice when you straight printed, right? You don't have to worry about going back and forth, right? Positives, negatives, and so you can print parts that can into the wall. Yeah, you can kind of do components and things like that. Yeah, and feel free to like bend it and move it and.
What was, this?
Oh,
up here?
yeah.
It's like you got some neon
Yeah, I totally
attached to it.
reminding me.
Skipping the good stuff.
Yeah, so yeah, this here. This is what these were going to be, but the castings didn't come out well. But yeah, it's multiple pieces, multiple plates. They have basically channels. This is just a flat piece in the back, so this is just all it is just two holes for the electrodes in the back here. Which yeah, that's I don't want to move around too much.
Essentially, you've got a printed front plate, you've bonded to a backer, and then,
Cast glass, yeah, all cast glass.
okay, so it's cast together.
Yes,
And then,
yes.
filling it with neon, and then you've got your traditional.
Electrodes.
Anode, cathode, whatever.
Yep,
back.
yep. And these are things that you get here from the Neon Studio.
Yeah.
Basically, yeah, and it's a low fire enamel that's compatible with the glass. You know, so it's like, yeah, it's a lot of practice, a lot of a lot of different tries there. Yeah, let's see if it's yeah, it's not really. With some of these channels, you can kind of control it a little bit, kind of you touch close to it or something like that. So again, it's kind of the prints were kind of getting a little bit messy, and that's where a lot of that artifacting is coming from.
It is hard to print in that wax material.
Yeah. Yeah, yeah.
But that's interesting. I've seen a couple of people try that. I think it works if you get it all right.
So yeah,
The tension between the belts seems to be absolutely critical.
Mhm.
Do you have any compliance in there to
Oh,
adjust that?
Not so. So it's really for the wax, and I pulled the wax through there. I've been able to feed the wax, you know, with pretty reliably.
Okay.
So kind of the next step is to really kind of attach it, motor, extruder, everything else.
Yeah, that's a good way to group it. Yeah, I'm just be interested to see if how much it deforms, or if it really matters that much, which you jam it through the nozzle. It may not matter as long as your flow rate is correct.
Right. Like,
Most of-
so this is where, you know, in injection molding, pressure becomes really critical. So in this geometry here, there was a bottleneck. And I had to change the geometry so that it wouldn't narrow down,
Oh, okay.
you know, and it's
Yeah,
just, that's just with pressure and
Are you preheating the mold?
it's in the kiln. I have a kiln with an exhaust vent. I take that off and I have this press mold that I cast with a press element.
So the
It's
mold
all-
is in the kiln.
Yes.
Okay.
Yes, exactly. And then I'm able to push through it with a rod.
Yeah.
Get the glass into the mold. Exactly. But then kind of, that's also still in process, but to actually put weight inside the kiln. So it doesn't require out, instead of like, you have to press every single one, you can load up a whole kiln and the whole thing is just pressed down automatically. Each one has its own weight. Basically,
Okay, yeah, just let that do the work.
exactly. Exactly. Yeah. Yeah, and you're welcome to pick it up if you want.
Tiny guy.
So yeah, it's based off of Warren project.
Yeah, sure, more. Simply. That's. Yeah, like better.
So this is a Trident, so there's this sub version of it, which is furnace for ants. They call it. Yeah, so this is a bit more on Trident boron. Yeah, you've got the three linear results. Are they independent? Yes. Yes, so there's a kind of like a future proofing, but okay, doing kind of non-planar printing. Yeah. So basically. Tried to hide some of the ugliness a little bit. Yeah, and it's all pretty, you know, pretty solid. Yeah, and it's what's nice about it is that it allows airflow, but then still allows for kind of site restriction as well.
What's the material?
ABS.
Yeah, definitely got the settings too. It's good.
Found a way to hide all the screws. Yeah. It's cool. It gives it a pretty good seal.
Looks great.
And that's ASA glass film. So that's high, yeah,
Here on the
yeah,
side,
yeah,
yeah,
yeah.
I was seeing that, I was wondering if that was ABS too.
That looks. The ASA glass film.
Yeah, that glass fill.
Yeah, yeah. But yeah. Yeah, and I have a boron 2.4 as well, modified it to be able to process polycarbonate as well.
Yeah. The glass fill, retardant fill really helps. Yeah. Shrink rate.
So it keeps from warping too much. Exactly.
So what's, I don't know. You said what's next? You wanted to try to do kind of a living hinge with.
Yes, and a borosilicate.
Yeah,
So this is kind of the upcoming summer project.
so you're depending on
Definitely.
the glass to flex that much.
If you do it small enough, yes. Yeah, I mean, may not get 180 degrees or something like that. It's worse, worst comes to worse. When you can have these kind of.
Yeah.
Be extended a little bit, something like that. Yeah, because have you worked much with glass?
Not that much.
So yeah, if you get it really thin, I mean, you make stringer or something, which will that's pretty thin. And so, it'll flex, and because the glass is amorphous, there's no fatigue.
Yeah.
So if you get it down thin enough, you can at least get, 30 degrees, 50, 60 degrees, something like that. Oh, yeah, business cards, you're welcome to that.
All like samples in the.
Yeah. This is the polycarbonate that I've printed. Different colors in there, materials. So I've done kind of photographs.
Oh, the lift thing.
Yeah, exactly.
Oh, is that the Tesla?
Yeah,
What,
so it's all glass again.
yeah, but what,
And
oh, no, it's not a lift bank. It's not
It's-
variable thickness.
it is. It's two pieces. So the blue. It's so a height field is pulled from the image.
Okay.
And it's digitally you can offset it so that the two are seating correctly. They're seating almost perfectly together. You tack fuse it and then you grind down the blue one. So that way
Oh,
it's a
okay.
lithophane, but you don't need a backlight.
I see. All right. So the
Mhm.
white material has an imprint in it. The blue material has an imprint in it. and
Exactly.
You fuse them together, grind the
Exactly.
front surface.
Exactly.
Okay. All right. So yeah, probably.
So that's the thing. Yeah, you don't need the backlight for it.
Yeah, it doesn't actually help that much. Yeah, you're just getting it through the gradient of the thickness.
And that's what's nice that you do have this kind of perfect grayscale.
Yeah,
No dots, no nothing.
it's cool.
And that's all done with these molds here. So it's all kind of pressed together. So these are slightly upsized. I was working with a smaller size when I was making these, but it's the same idea.
Yeah.
Tesla.
All right. That's
Yeah,
yeah.
yeah,
That's another
so-
full one you should show people. That's very unique.
Yeah, I was looking for a kind of a public domain photograph.
Yeah.
And most of them were just very bearded individuals, and this process doesn't really like very fine lines, so beard doesn't come out well. Like Tesla was the only person without a beard. Like, all right, Tesla, let's do it. Why not? Why not? So, yeah, I don't know, trying to mix everything up and come up with something new.
And he cannot sue you for rights.
No. No. Very dense, very dense.
Safe bet.
Yeah, I wouldn't have expected like a neon lab here.
Yeah, right.
I was pretty surprised as well.
Are you familiar with, have you been working on that before, or?
I had a friend who used to make neon for a living.
Yeah.
Wasn't a lab, it's just his studio. But, yeah, I don't know, I guess.
Yeah.
I don't know what evergreen.
We have a neon studio.
Yeah, I don't know what their MO is.
A lot of hidden stuff. So yeah, the barbers and that, leave that one alone, but bombarder, so that's the actual process of taking the neon tube and getting it down to a vacuum, basically the gas into the tube.
Oh, okay, yeah.
Yeah, you have to kind of clean the tube and heat it up.
Yeah, I didn't know that part.
Yeah, no, that's. Yeah, that's all.
Sorry.
Was the little Tesla picture not, I feel like it was initially part of the,
Yeah, I told.
oh, I see. Well,
All right.
Hey, over at board,
What do you do there?
manage a couple of teams. We make mock-ups and prototypes.
then I go,
Does, advanced material process development.
but then you're,
We have two good cells, and one of them is, the spray additive process, the valuable spray additive. The other one is, friction stir additive.
also a difference for the
Pretty rare.
Friction stir additive. I know friction welding.
So you have friction welding, but yeah, friction stir welding is kind of a neat process. We didn't develop it, but we're developing our own version of it. It doesn't create highly accurate shapes, it's kind of a net shaping process. Right. But it's similar, right? Like they're essentially extruding material as your friction stir welding on it. So it builds up in a similar way.
I mean, is in the additives and still water or something like that.
So it depends on the process. But we've got a big, fairly big functional machine. It's come on.
Yeah, oh, that's what I'm saying, that.
Yeah. They're out of Virginia. They basically put a large seed set in. Put it head on it. They have a square rod down the center.
Should be ready. You said in 30 minutes.
And it's like based on like low vibrations or something like that, or it's spinning. So.
But if you want,
What?
or if you want, you can take an Uber or something.
No.
Yeah.
Combination of research, development work in one way.
I need to give them some of the time.
I'm just one.
Like, the other time, doing mock-ups, but they have like, you can